Okay, so my name is Adam, and
I'm Giselle.
and we are the UOttawa campus leaders for the undergraduate science case competition 2022 to 2023. And we're going to be hosting an information session today. So, who's behind UOttawa Synapse? So, URI, which is the Undergraduate Research Initiative, is the overhead of the UOttawa Synapse Club. And basically, this is one of their initiatives that they're doing. Okay, so yeah, I'm a campus leader. Giselle is also a campus leader, and I think relevant people for anybody else who'd be participating in this competition would be Mary Lou and Sarah. So Mary Lou is the mentorship lead, and Sarah is the scientific advisor. Now, first step, if you want to participate in the club, is to register. Now, registration closes October 28th, so pretty soon. And it'll be teams of 1 to 4. You can do it alone, but I think it'd be wiser to try to find a team. And if you don't have a team, don't worry, we're going to get into that later in the presentation. Now, there is an entrance cost, which is $30 per team. So just one person needs to pay the fee when you sign up to make the team. There are going to be 2 divisions. So lower division is going to be between students who are in their first year and their second year. And then the upper division is for students who are in their third year and above. Now, like I was about to say, so if anybody is, let's say there's a team, and this is what I was going for. Any student taking more than 3 third-year classes as of November 1st is considered an upper year contestant, and any first or second year student can register with the upper year students in the upper division.
Okay, so step 2 is the written round. Okay, so basically for this step, what you're going to be doing is you're going to propose an original research idea. So this is a step where you're going to do all your research. You're going to find your topic. So our topic was neuroscience in the future for this year. So you're going to find some scientific literature to support it because you want to make sure it's all following the scientific process, and it's all going to be based around your research idea. And we're going to go into this later, but you can use the university library account to access scientific literature. So you can, find good, reputable sources to support your research idea. And so this original research proposal is due November 22nd at midnight, and it's going to be submitted online. And another reason, why do you want to participate in this competition? So this is a really good opportunity to get a lot of research experience, a lot of intro into the scientific community. So I actually participated in Synapse last year, and I found it was an amazing opportunity to not only find people who are interested in the same things as you, but also like Adam had said before, we have mentors and we have lots of opportunities for you to gain lots of scientific experience. So like it says here, you get a lot of practical skills, essential in research. It's obviously, I'm sure you guys all know, it's hard to find research experience in university as an undergrad. So this is a really, really good opportunity. And not only is it research experience, you get to decide and you get to pick the topic. Like it says here, it's great for your CV, medical school application, your resume, and if you do win, you get to publish your research abstract and proposal in a journal. Okay, so this is a little bit more about our topic, neuroscience. So there's many branches. We have cellular and molecular neuroscience, cognitive and behavioral neuroscience, developmental neuroscience, computational neuroscience, and a lot of other topics. So this is just to show you guys the options you have, because it doesn't have to be just when you say neuroscience, it's not just that word, right? You can approach it from any perspective. Whatever your background is, whatever degree you're taking, you can connect it to this.
Okay, so just one more note about this slide. So if anyone has any questions about what we mean by these branches, so for cellular and molecular branches of neuroscience, it's just as an example, it'd be studying the nervous system at the cellular level. So for example, like neurons, glial cells, and any other potential cells that you may find in the nervous system. Now, for cognitive and behavioral neuroscience, it's as an example, like studying the processes that underlie mental processes, so thoughts, behaviors, emotions, decision-making. And for developmental and computational neuroscience, so this is more towards how the brain forms, grows, and changes. And computational, as I'm sure you guys are very aware of this, it's more mathematical modeling and more of a systems computer science approach to neural systems and information processing.
Okay, so now we're going to continue to an introductory video.
For centuries, doctors and scientists have tried to unlock the mysteries of the human brain. How is it organized?
Emotions are centered in the lower part of the brain.
Which areas control different mental functions? And how is it all wired together to generate our subjective psychological experience? For the past 100 years, neuroscientists have approached the brain like mapmakers, charting its features and activities within well-defined boundaries. The prefrontal cortex is celebrated as the seat of rationality. The motor cortex plans and coordinates movement. The somatosensory cortex and parietal lobes control our perception of the physical world. The temporal lobes process memories, language, and emotion. The occipital lobe processes and integrates visual information, and the cerebellum helps execute our body's motor commands.
Scientists have looked at the brain through the lens of our beliefs about what it means to be human. So when we're looking at parts of the brain and trying to figure out what they do, scientists are usually using beliefs about what makes a human mind. And some of those ideas you can trace all the way back to Plato.
But researchers are finding problems with this picture. Recent studies of traditional categories of cognitive brain functions, like memory, show surprising amounts of activity that overlap different parts of the brain. So much that the simple map and its strict categories lose their meaning.
The way that we've been conceptualizing the mind doesn't map very well at all to the functions of different systems in the brain.
These kinds of distinctions are very subjective, and it's probably better to try to look at the brain and figure out what its organizational properties are without appealing to these culturally laden categories which aren't respected by the brain.
Russell Poldrack is doing just that. At his lab at Stanford University, he's taking a computational approach to understanding the organizing features of our mind.
If you have people perform, a bunch of different psychological tasks that vary in the psychological functions that we think they engage, let's collect a bunch of data on a bunch of different tasks and ask the data what kind of structure there is.
Poldrack's lab used machine learning to try to isolate neural activity related to memory recall. But rather than simply mapping into memory centers, the data correlated with more general constructs of activity, ones for which we don't yet have names.
What that has shown us in some cases is that things that we might have thought were measuring the same thing really don't seem to be measuring the same thing at all. I think we need to fundamentally rethink how we conceptualize the functions of the brain. Within neuroscience, there's a broad agreement that the brain is a computational machine, and we need to understand what the computations are that it's doing, and that we should be able to ultimately understand psychological function in terms of those computations. Part of the challenge here is we don't really even have a good language for describing those computations other than math. So it raises this interesting question of whether we're going to end up with models of the brain that are really good at predicting activity of the brain, but that we can't sort of give human understandable explanations to.
Okay, so what can you write the proposal on? Now, we had given some previous examples of, for example, like cellular and molecular neuroscience, but you can actually approach this from any perspective. So as long as you are keeping it relevant to neuroscience, now it doesn't need to be an example that we just given today. It can be from any field or discipline in neuroscience that you find that you are comfortable writing on. But again, you can use knowledge from any and every field of STEM, and again, STEAM being art and A. But keep in mind, you cannot write your proposal on something that is like clinical. So you shouldn't have anything in mind that's like about testing it on people. So required content for the case competition is an abstract, which is not a part of the 1,000 word limit. So you must have 5 to 10 keywords directly beneath the abstract that are relating to your proposal. And it must be related to a scientific background. And You must have a hypothesis, research idea and aims, and be able to have basically explain the significance of your experiment in your writing. Now, you should be having a research approach and methodology section, and again, a definitions sheet, which is also independent of the 1,000 word limit, and a reference section as well, which is in APA format and also independent of the 1,000 word limit. Now, you can include diagrams and figures, and we're going to be touching on those later, but this is also just if you believe that it will help in your case.
So the abstract, as Adam was talking about, is also independent of the 1,000 word limit. So if you guys are in STEM, you know what an abstract is, and it's just like a little summary or blurb of what you're going to be talking about. So it's going to be at the beginning of your proposal, and you're going to use this to attract your reader, or, to really like sell your research idea. And this is the first thing that a judge sees. So make sure it's really good, it's really well thought out, and shows them what you want to talk about and what you're going to study. Yeah, so also the research abstract should not include too many specifics. You're not going to do your whole paper in this like 250 word abstract. So it's just a little short summary. And yeah, it says that it should be written last because it summarizes everything. So this is the best way to do your abstract, kind of figure out everything, your methodology, your diagrams, all your, methods and stuff. And then you're going to do your abstract. So here's a little flow chart of how to come up with the research idea. So we have a main topic, which is neuroscience in the future. And then from that, you're gonna, like it says, highlight a problem. So one thing you want to talk about, then fully understand the different factors involved in the problem. So you can kind of like elaborate on these factors, and then you can link ideas and propose a solution to the problem, which is the main like overall goal of this competition. Okay, so this is another aspect of the competition, the background information. So once again, there's a flow chart. So at the top, you have the problem you chose and the impact. So as we remember from the last slide, you had to pick like one main problem. Then what characterizes your problem, and you're just going to give everyone a little description. Research in the field that provides insight that can lead to a solution. So this is where you kind of go like a little bit deeper. You find research. And then you start connecting ideas, list of facts, make links, follow a cohesive progression. So this is the scientific method, and then the final results. So here you hit anticipated outcomes, but you ultimately save details for the hypothesis, because obviously we're not doing the whole project. You're just like submitting a research proposal. So this is an example of a previous case, and in case you're not sure where to go, or this seems like a lot of words, this is just an example. So for example, one of the topics in the previous years was cannabis. So we had our main like problem was postmenopausal osteoporosis is responsible for many fractures. And then going deeper, it's very common amongst women over 50 years of age. Lack of estrogen after menopause causes bone loss. And then various components of cannabis have been shown to promote healing in individuals with fractures. So now you're singling in on one thing. Then your research is, if cannabis components can help in healing fractures, can they help in increasing bone density in postmenopausal osteoporosis? So this is a question that you're asking. And then cannabis is found to be effective in increasing bone density. Describe the factors that encourage bone growth and ways to optimize them. Yeah, so that was a little bit of like a flow chart showing your thought process for this topic. So obviously cannabis was a like wider topic, and then from there you picked one kind of related to the STEM field. Here's an example. So as we were saying before, an abstract should be written at the end, and it kind of summarizes everything that happened in your paper. So one of the topics last year was about the climate change crisis and connecting that to like a research topic. So this is I'm just going to leave it on the screen if you guys want to go through it. So it'll show that, we summarize the methods, we summarize like what we talked about, and it really gives you an idea of what the topic is and what's going to be happening, what our research idea is. So yeah, it's just an example of an abstract that we'll leave up there.
Okay, so for your research idea and your hypothesis, so before you even begin writing your abstract, you want to keep it simple. So again, this isn't sci-fi. You keep it grounded, and you still want to be balancing your creativeness with something that could also be practical and potentially publishable, right? So the graders will be So when you're actually submitting your proposal and you're going to be tested or not tested, you're going to be graded. Now, the professors will be looking for something that's actually a testable research idea that's still creative and is still also kind of demonstrating that neuroscience is important and how you can have an idea. So on your side, how you can have an idea and kind of develop a plan and get an idea of how other researchers go about making research proposals. So you need to have a methodology when you're preparing your research proposal. So an example of this is a control group. Now, you need to be thinking when you're making your methodology, why would you have this certain, why would you have this method of going about collecting your data in your proposal? So when you're doing this, when you're writing, you don't want to keep it in point form. We need paragraphs only, and you're welcome to be using personal diagrams if you choose to. So this is an example of a methodology diagram from a previous year, I believe. So you can see here, this was made by the individual who was making the proposal. So okay, so for writing style, keep it scientific. Don't use any unnecessary jargon or slang words. So the judges are not necessarily going to be experts in the branch of neuroscience that you're writing in, but anything that you're talking about, anything that you think may be too specific, try to explain any new terms, acronyms, or processes. Yeah, don't assume that they know everything that you're writing about, even though they may be general experts in that field. Now, proofread, make sure you don't submit a proposal that is filled with grammatical errors or spelling mistakes. Yeah, it would not leave a good impression on the rater. So if you're looking for any publications, the UOttawa Library website, so the Omni database, you can be searching for keywords and find any research paper or abstract, for example, that the University of Ottawa is able to license out and give access to its students. Also, there are other databases available like the Web of Science and PubMed. Now, for UOttawa, as UOttawa students, if you ever need to actually access most databases, you should be able to sign in with your UOttawa email. And if you aren't able to do that directly on their website, you can do so through Omni, the Omni database. It's part of the UOttawa Library website, and you can access these sites from that way. Now, if you find any articles that you'd like to use, you should be having a reference section at the end of your research proposal. So if you want to save time and not have to go through everything manually, save the articles, make sure that you have all the key details, and then you can also put everything into a reference manager. So Mendeley or Zotero, for example. So this is the UOttawa Library website. Yeah, so if you don't have a team member, like I was saying, so if you'd like to participate, you don't have 3 more people, for example, to do the proposal with, you can actually join 2 of our Discord servers, I believe. No, we have 1 Discord server and there are 2 channels within it. So either for students who are in the lower end or the upper division. Now, on our website, when you sign up, you can also fill out a form and then from there you can find a partner if you'd like. Now, borrowing a research professional. Now, you can actually, when you're writing your research proposal, you can email us to book a time for consultation. Now, consultations are a maximum of 20 to 30 minutes long. We won't write the proposal for you, but if you guys have any questions, maybe tips, for example, we can guide you with that. So this is an example of the grading scale, how the judges will be critiquing your research proposals. So you can pause the video and see from here the different criteria that you're going to be rated on. So yeah, if you guys have any questions, you could email us at the UOttawa email listed and as well the general email on the screen. Now you can also contact us. You guys should all be following our Instagram account. The @ is listed on the screen. I think that QR code would take you to the website. So you guys can register from there.
Thank you so much for joining our info session. So remember that this is recorded, so you can always watch the Zoom later to find out what you missed. And you can always just email the contact emails listed there, or follow the Instagram if you just want quick updates and reminders that we'll be posting regularly.